All right, welcome everyone to our first IRIS-HEP demo day. We are very happy to actually see that we not only have quite a few people on Zoom, but also here at the room in CERN. It feels nice to be able to actually be all in the same room to talk about stuff here. What is this meeting about today? It's a different format from the workshops we've had in the past. Today is a bit more technical. We have short contributions on a variety of topics showing essentially what people have been up to, all the very latest cutting edge developments that took place. So that should be quite exciting. Quite a few topics here that we will go through. The format will be short talks. We have something like 15 minutes or so assigned per contribution. Please let the respective speakers get through that, and then we have some time to immediately take questions that are directly concerning those topics. And we have a big discussion block scheduled at the end as well, where we can then discuss also with a view of everything that we've seen and went through today. I have added, or we have added here on the agenda, a link to a Google Doc with the possibility for you to take live notes and record questions that you may have. Sharing this also now in the Zoom chat. You should have access to this, so please feel free to make use of that Google Doc. And lastly, this is demo day number 1, which means there will be a demo day number 2. And that is already scheduled February 24th. Indico is linked in the Google Doc. So please mark that on your calendars so you can come back to this format in about 2 months where you will see further updates. And I think that's everything for introduction that's needed. Anything I'm forgetting? Oksana, all good?
Perfect. Yes.
I think then with that, we'll jump directly into our first contribution.
Alex, can I ask a very quick question? We have something called Dependency Management for Complex Analyses at coffea-casa facility in the notes, but I don't see anything.
We will fix the notes. Yeah, that was shifted to next round.
Okay, perfect. I'll just delete it.
Thanks.
Thanks.
All right, then our first contribution is going to be Elliott about inference servers at coffea-casa. And you'll share from your setup?
Yep, I will. All right, hi everybody. I'm Elliott, and yeah, as Alex mentioned, I'll talk about our first steps towards using inference server at coffea-casa facility. So, and I would like to briefly advertise IRIS-HEP topical meeting that'll be on January 18th. I have Indico link there that you can visit. I have the slides linked in the Indico. That will be inference with Triton at Fermilab. Speakers Claire Savard and Lindsay Gray, and they've helped us understand how the setup with Triton works. So check that out, definitely. So I'll get right into it. So we're using NVIDIA Triton. So it is inference server that can take columns as input, perform machine learning inference in external server, and then outputs those predictions back. So you can either use it with a GPU or CPU or multiple GPUs. As of right now, we currently have 1 GPU available at UNO. NVIDIA Triton is useful for inference on if you have a large amount of data and or you have complicated machine learning models. And you can also run inference using multiple models at the same time, which is an option that we'll explore in the future. And you have 2 client options for communicating with the server, gRPC or HTTP. An example I'll be talking about today, I'm using gRPC. So this is a diagram of how we are currently interfacing NVIDIA Triton with coffea-casa. So we have the models, the machine learning models loaded into persistence volume that NVIDIA Triton has access to, unlike so instead of Minio, we have persistence volume for now. And you use the HTTP or gRPC client to communicate with the server, and you can load data into it and then return columns. So I will keep going, but this is there in case anyone wants to reference for more details. And yeah, as I mentioned, we only have one GPU right now. So I'll talk about the details of how loading a model works. So first, obviously, you have to train the model and save it in the appropriate format. Multiple backends are supported, including Onyx Runtime TensorFlow, PyTorch, TorchScript, and TensorRT. The example I'm going to be talking or using today uses PyTorch, TorchScript, and there are a few others as well. But once you have the model in the appropriate format, you need to create the model directory. The directory needs to be named with the model name, and then within that directory, you can have multiple version directories. In this very simple example, we have one named 1. However, you can have multiple versions, 1, 2, 3, 4, etc. And in each of those, you have the model, which needs to be named model dot whatever format it is in. And then you also need in the model repository a config file, which I'll talk about more in detail about how to write. So this is how you create config file. You need to have model name that is the same as the model name in the directory I showed on the previous slide. You need to specify which platform. In my example, it's PyTorch, libtorch. And you can specify max batch size, which is maximum batch size to use for inference. It must be compatible with the model, so you can't have a number that is larger than what your model can handle. And you can also set it to 0, and that is how you do dynamic batching. So you specify your input with however many input variables. Their names must be in the form name __ index. And then you specify dimensions. And if you have max batch size, that's really hard to say, that is greater than 0, it assumes an extra dimension of -1, which is any arbitrary number. However, if you want to set max batch size to 0, this will assume you need to actually specify the -1 to come first because it won't automatically do it. And this is how you implement dynamic batching. So having Triton do the batching for you instead of manually doing it. So then after that, you add the model directory to the persistent volume, which is available directly from the notebook pod. And ideally, or this is how it should work right now, is you can load the model into Triton using curl command right here. We're having some issues with this right now. So I'm going to show this a short demo that I made real quick. Maybe I'll make the text a little bit bigger. It's not working. Okay. Well, hopefully people can read this.
Yeah, I think it's okay.
Okay, so
Your eyes are better than mine.
You could connect on your laptop.
So to demonstrate current functionality of inference with Triton, I've created just some toy data. So just randomly generated data from 2 different classes, signal and background. So I have some toy events. And then I have trained a very simple neural network in PyTorch with just linear transformations and Rayleigh activation functions. So I have basically repeated what I already have in the slides, but it's more specific to this example if people want to read through that. But note
Just
that I...
Quickly, how many inputs are there in this model?
How many inputs?
Yeah. So is that just one floating point number? Or, oh no, 64 by 4.
Yeah, so there are these four features for each
features,
of them.
okay.
Yeah, and then I'm using batch sizes for that, yeah. So here's my config file, which is the same that I showed in the slides, except note that I did set batch size to 0, so I'm using dynamic batching, and I have the batch dimension listed first, which is necessary for dynamic batching. So we can check just to make sure this model is loaded correctly by using this curl command, and it is because I can see this output right here. And if you instead see error request for unknown model, that means the model is not loaded, and that's our current method of telling whether a model is loaded or not. This is something we want to improve on in the future. Note, actually loading and unloading models is not working very well at the moment, but these are commands that you would use to load or unload using curl. So now that we know that the model is loaded, we can start to perform inference. So I have some options right here. So verbose output for gRPC client. This is the URL for the inference server, my model name, binary classifier, and then I don't have any model versions. I just have one, so I can have empty string. So I have a coffee processor here that I will perform inference in. So initialize with this histogram, which I will load data into and load the inference results into, and then specify model information. And then here in the process step is where I'm actually using the inference request. So I'm loading in the features from my toy data, and then I need to create the gRPC client, which communicates with the inference server. So I specify the URL, and now I have my client, and I can use this client to get information about the binary classifier model that I have. So I can use the method get model data, and I can get things like the name of the input variable, the data type of the input variable, and the output name. And then I need to actually configure and set the input data. So for input, so I need to tell it what the input name is. I need to tell it the shape of the input features and the data type. And then I can fill it with the data that I want to perform inference on. And then I also need to tell it the output name. And then here is where I actually make the inference request using dynamic batching. So specify the model name, put in the inputs, specify the output, and then this is performing the inference, and then just converting to NumPy at the end. And then I save the data, and I'm closing the client at the end of this step. So let's try. Oh, this is just a schema to load the toy data. Nothing special there. And paths to the toy data that I made. So I have the futures executors, which will have local workers, because we can, with our current setup, we only use local workers. And then, let's see. Yep, that's just ran the inference. So now I have the results from the inference stored in all histograms. And then we can look at the results. So this is what it might look like when we use Triton inference with coffee. So I have my can plot and separate by the signal predictions and background predictions. So yeah, that's just end of the brief demonstration. Let me go back to the presentation, and I'll briefly talk about current issues and future steps. Well, we saw some of the current issues, so I'll talk about them in just a brief list right now. Right now, the user cannot actually see the server logs, which makes it a bit hard to debug and figure out what's going on.
So many things have this problem.
So we need to find the most user-friendly way to load models. It's really nice to be able to just copy the model repository over to MNT, but it is less easy for a user to check if a model is loaded for the above reason, and it's a bit buggy to load or unload models right now. We're currently using explicit update model policy, but we're experiencing some issues with it currently. And there's also issue with sharing the same persistence volume between users, GitHub issue linked here. And as I mentioned, we're currently only using local workers because the workers need access to the models and the persistent volume, or S3 access through ServiceX. So next steps, we will define how we will do training in this setup and how to integrate it into a pipeline. We want to experiment with requesting inference for multiple models at once and experiment with more complex models. And this will be done by looking at different applications in the Analysis Grand Challenge notebook. So that's all I have for today. I hope I did okay on time.
You're good. Yeah. Thank you very much. It's great to see this working. Always good to see the live demo work successfully. And like also thanks for all the work that went into actually getting to this point. I think we have a brief moment to take immediate questions or like comments directly related to Elliott's presentation. And Triton.
Can I ask a question?
Go ahead.
If there's somebody
can you make sure the microphones are like on this side? They like should be lighting up in red.
Owl is gonna pick up everything.
We have audio running through the room. Not
okay. So earlier I was talking to the. Okay. Can folks on Zoom hear me?
Yep.
Yeah.
Perfect. Okay. Is NVIDIA Triton a piece of software? Or is it like a complete machine that's been purchased?
It's a software.
It's okay. So it's a.
So you have like files running in Kubernetes. So you have like deployment.
Okay. Okay, great. And it's just you run it in a way that is connected or can see a graphics card.
Yeah.
Good. Okay. And does it do like partitioning? Can you partition a graphics card in so you could run multiple models? It supports that?
So actually we have very basic setup, but
okay, perfect.
Thermalin has much more complex in the terms that they have more GPUs, they're sharing them. There is like possibility actually to enable, let's say, auto balancing. So depending how much GPUs you would like to have, there is like mechanism through the Prometheus to pick up.
No, this is just like the various analysis facilities. And then the only other question.
One second, Bert. I'm assuming your comment might be on that.
Gord. So we have not only can it partition GPUs using like the latest A100 using multi-instance GPUs, so you can chop it up into bits, which is actually what we're doing at the lab. It also is really good about handling multiple models, shifting them in and out of memory as needed, making copies of the models depending on the GPU cores, right? It's an NVIDIA product to maximize NVIDIA use, so it's maybe not that surprising.
Well, it may be maximizing purchasing of NVIDIA products, which might be a slightly different goal, but okay, perfect. Thanks. And just the other question, you had curl commands at some points, and then you used a nice library, and the interface with the library that really fit in. The curl command's basically just status and telling it where to go look for a model to load it in. So you interact almost not at all with the curl commands.
Yeah, the curl command I was just using to check if a model is loaded.
Okay, so it's just basically status. And
yeah,
perfect. It's like a dashboard.
Do the same through Python.
Yeah.
Triton client library as well. So.
I did not do that for this
Yeah.
demo, but yeah.
Okay, but you could. You could have. Okay, perfect. Thanks.
That.
Yeah, this is real quick. So you require POSIX access for the storage, or is it coded up that you don't really care? It's could you say currently use persistent volume?
So there is like two different setups that we have in this moment. At UNL, we did the basic one where we basically just mounted, models, let's say this persistent volume, we mounted to all users' notebooks, and this was the easiest way to test. Well, for example, in Fermilab, they have Minio, where they use, user load models through Minio interface. What we were thinking to do at UNL is we wanted to keep this model because it's actually, Elliott gave us feedback that he likes the way that you can easily load model being directly in the kind of like your analysis facility environment. So you just like copy it basically. From this point of view, you're right, it's kind of a nice feature, but we also want to have possibility to access it through S3. So like John or like me, we will look in some moment to be able to use ServiceX from this point of view, and kind of like this will be our general approach for also ServiceX, because we don't want to have Minio, we want to have everything integrated on the level of ServiceX.
So S3.
Okay, Mark, I saw you briefly had your hand up.
I put it down because it was getting low. So Ben Gluski had, so we had done some work on this with a postdoc guy, and Ben standing up this Triton server at Illinois, and it was based on Lindsay's instructions. And the one thing I wanted to mention is that, as I recall, you were able to stand the service up actually in the user space. It didn't require privileged access. It sounds like you have a service that's been stood up for you that sits and listens with this gRPC. But I was just thinking, since you have no access to the server log, I don't know if it's possible, but you may be able to stand up a local instance and be able to debug it a little bit better. But Ben, am I remembering right? This was actually stood up in the user space, right? It doesn't have to be a root privileged service, if I understand.
It was a long time ago.
Or am I wrong on that?
All I remember is that it was very painful. That's the only thing I can remember from the experience.
Yeah, I remember that. Okay.
All right.
Okay.
Anyway. Thanks, Ben.
Sure.
I think let's move on to the next contribution, and we will continue now with ServiceX, and Tal will show us how we can get root files out of an uproot transform in ServiceX.
Yes, that is so I can, I think, make it a bit bigger, which I just tested. So something like this, I think, is okay, right?
Mm-hmm.
Perfect. Ask Gordon. Even I can read that.
Okay. Okay, so yeah, so to showcase this functionality, I'm sort of reusing an AGC notebook where we use Atlas Open Data for Higgs to Z to for lepton analysis. So sort of, yeah, I think I'll just start, and as we go through, I'll talk about the both the software aspects and also a bit of the physics. But not too much. Well, because we're just doing some imports and setting some global variables. All right. So like I said, this is using the Atlas Open Dataset for this H2ZZ to for lepton analysis. There are some nice clickable links in the Indico. You can find a link to this specific notebook as well, just on Git. So you can click on everything. What's important to note, especially for the physicists among us, is that this is just a technical demonstration. It's not a real full analysis, even though we are showcasing quite a bit of the aspects of a full-fledged analysis. It's not an actual physical result that will roll out. Well, I guess it is, but it's not one that one would, publish in a paper or something. So this is the main sort of workflow that's going to be used. As part of the analysis systems group. And in particular, we are going to use ServiceX as the data delivery tool. Then we're going to specify some query using FunkADL to select the events and the columns that we want. We're going to handle the data with awkward. We're going to produce the histograms with coffee, handle the histograms with hist, okay, visualize it with these tools, handle the root files with uproot. And finally, and I won't put too much attention to this, we will make statistical models and inference with cabinetry and PyHF. But because most of the showcase today is about the handling of root files with ServiceX, it's mostly going to be this first part that I'll spend the time on. Okay, so I kind of already said this. We define a process, files to process. We query them, we set up a query with FunkADL and then pass that through ServiceX to extract the specific data that we want. Okay, pass it to coffee, save the histograms with uproot, and then make it into a statistical model with cabinetry. So I don't think everybody will be able to run this out of the box right now because it's using a fairly recent endpoint for ServiceX. At this specific address. So many thanks to Ben for setting this up very quickly. Okay, so first let's start by looking at the files that we're going to use. So in this case, we have 3 specific background models and the data that we're going to look at. So specifically, we have 4 data groups, then some TT-bar processes, some diboson processes, and then some information for the histograms. So let's run that. Now we're going to set up a query with FunkADL. This basically specifies all the columns and scale factors and particle particle information that we're going to be interested in. So we're not executing and we're not really running anything yet. This is just defining everything so far. This is the first part where we're going to start really doing anything. So now that we have the query defined with FunkADL, we create a dummy data set. This doesn't really exist, but we're just using it to construct the specific language of the query. So this is just a dummy data set. We set it to return castle, meaning that we don't contact ServiceX yet. This is only telling it to return the castle string for containing the query that it would have otherwise sent. And then we do the actual creation. So let's run that. And now this is one of the new things. So we're gonna contact ServiceX. Let me actually start running this because it does take about 2 minutes. We make a new dictionary. Then we're going to run through the files in the input files dictionary. So this is just addresses to the Atlas Open data. We're going to make a ServiceX dataset using those specific list of files, pointing to the new backend that I mentioned, and we're not using any cached files right now. And then we're gonna, for each of those datasets, we're gonna send a query to ServiceX and get a URI pointing to a nicely cached file that contains the specific events and columns that we want. So this is what's going on right now. And then once we have those files, so essentially a list of URLs, we put them in a new dictionary called file set, which contains files here and some metadata, in this case only the name of the dataset, but you can put anything else there that you want, and you can use it later on in the coffee processor, for example, to make specific requirements on those values. So this is gonna, I think, take a little bit more. So I can talk a little bit about, for example, what it was like for me as a physicist to use all these tools. Because I'm not a software engineer or anything by trade. I think in the end, I mean, considering that we're basically running a full analysis here, the experience is very good. You do run into some issues, and we had to, as always with these kinds of things that we want to get working, we had some last minute things to fix. I think in the end, it was quite easy. But you do have to sort of get through the initial sort of some unintuitiveness of some of the tools. This is maybe partly because I'm used to this sort of old root-based, workflow that analyses in Atlas and CMS, etc. use. So I think there is some ground there to be gained to make things a bit easier for established analyzers from those big experiments to start using these tools. But I don't think it's
As you're waiting, can you tell me a little bit about how many events this is, or I can't tell if it's a megabyte or a gigabyte.
Half a gigabyte or so. The size is quite small. Yeah. I don't know the number of events.
So it's probably CPU bound.
I think this is mostly overhead of like setting up and like tearing down all the infrastructure. So I think the pure CPU cost is fairly small. I think
Okay, sorry, good. I stalled enough.
Yeah, that's fine. Yeah, so it took just over 2 minutes, and now we have this nice dictionary that contains the addresses of the queried files, which is now ready to pass to Coffee. So it looks a little ugly like this because the addresses are so long, but you can see we have data where we have 4 addresses, then we have this particular background, etc. So now we pass this. We're going to start passing this to Coffee. We have a little function that we can use later to get the correct cross-section weights for each specific process. This just points to some file elsewhere that contains this information. Now we define some cuts for the objects that we want. So because this is analysis looking for ZZ to 4 leptons, we are only interested in either 4 electrons, 4 muons, or 2 electrons, 2 muons. So this little function essentially gives the requirement for that specific cut. Now we start setting up the Coffee processor. So this is essentially the whole analysis, basically. We start loading the events. Then we construct the 4 vectors for the leptons, just containing PT, eta, phi, and the energy. We calculate their invariant mass of all 4 leptons, and then we start filling histograms. So here we're using those predefined low and high edges and a number of bins. And here we start doing the systematics. So this is essentially the same thing happening, but we have a set of scale variations and other uncertainties that we want to vary and use later on in the statistical inference part to use for uncertainty calculations. And then depending on what the data set is, if it's data, we just fill the histogram, of course. We don't know anything about scale variations or Monte Carlo uncertainties or whatever. And otherwise, we fill all the specific nominal histograms or systematic related histograms. So let's execute that as well. And then we come to the function that actually does this. So we define our executor, we define the process, the runner that we feed into this line here where we produce all histograms. There we go. And then in the end, we get some histograms for the data and some histograms for the Monte Carlo. And so let's run this. And this is really quick. I think this takes about 15 seconds. And that is because we have already done all of the specific cuts and selected all of the events and columns that we had. Before this notebook was using a combined ServiceX Coffee instance, and we had to basically do this step, do both of those steps in one go. But now, because we have already cached those specific files, we can just access them right away with Coffee. By the way, I forgot to mention that right now we're using root files, and so the new backend is with uproot writing to root files. You can also still just use Parquet files. It works in the exact same way. So this is the main interesting new stuff that we just saw. I'll just run through this for sort of completeness sake, because it is kind of cool that what we did just now gives us these really cool looking histograms. So this is just the data Monte Carlo plot. Nothing yet applied to the background, only statistical uncertainty. You can save those with uproot, and then we can start building our workspace and running a fit with cabinetry and IRIS-HEP. So let's start doing that. Here we see everything that we so far have, samples. These are our systematics in this case, so I won't go through them. Here we actually create the workspace with cabinetry, also super quick. Create the model and the fit results, and then we can start visualizing what we have. So these are the pull plots, for example. For the non-physicists, I think it's not exactly necessary to understand what's going on here. It's just one of the important parts of making sure that your analysis is trustworthy and robust. Here we visualize a correlation matrix. This is a bit more well known, I think. You just see to what extent specific systematic uncertainties are correlated with one another. And then we can start actually doing the fit and seeing what the post-fit prediction looks like. So here we can actually use the information in the data to adjust our background prediction and to reduce the systematic uncertainties on that as well. So this is in the end what we end up with, and we have here our nice little signal contribution sitting nicely at the 125 GeV Higgs mass. And then the last thing, we can actually also extract the specific CLS, CLS value for this sort of mock measurement, and in this case it's 0.535. Some final remarks. Actually, I don't think I'll go through this because this is sort of about the whole thing, and like I said, this was mostly to showcase the ServiceX and root writing functionality. So thank you.
Thank you very much. 2 out of 2 live demos that work flawlessly, which is great. And also thanks everyone, because there was quite a bit of work behind the scenes to get ServiceX uproot transformer writing out root files. So I very much appreciate all the work that went into this, because this new functionality now, I think, makes some of the workflows and patterns that I think are very user-friendly possible that previously weren't. All right, we have a few minutes for questions and comments.
I have a couple of questions near the top of the notebook when there's like the looping over data sets, like you're creating multiple data sets. Is this because like the open data, the ID finder can't just say, here's this whole data set, because you're doing the same query over each one. So you're making multiple requests, which seems inefficient. But is it because the ID finder can't tell you the whole thing?
I don't actually know what the ID finder can and cannot do.
So I think, Ben, 2 things. One is for the purposes of this notebook, you need to keep those 4 things separate. You don't want to, it's not just a matter of treating them all as a single data set. You actually need to know which data comes from which data set. And I think if you scroll down, they end up writing different colors or something like that.
Yeah, no, exactly. So it's very important that we know, that we can look at, for example, the coffee processor. It's very important that we know what is data, what is Monte Carlo, and which specific process is which. For example, if we have some TT bar process, I'm just saying something that might need specific systematic uncertainties that another process doesn't know. Etc. So in the end, indeed, it's pretty important. Here we have separate.
Okay. Right.
But your point is actually also well taken. As Alex has pointed out and others, why not have something like a data set group, which is just a list of data sets, where you want to do the same. The same query on all those data sets. Why not make that even easier so you don't have to have this explicit loop? And that's certainly a feature that could be added to the client, the front end. And that would still be 4 queries from the point of view of ServiceX. However, from the point of view of the user, it would, I think, significantly shorten this.
Yeah, and it's very similar to the same issue with running on many trees. I mean, it's
Right.
different.
Yeah.
Those are in the same file, but it's the
Yes,
same idea.
but it's the
You're
same.
running different queries, but the same, but on different sets.
Yeah.
Yongyan, I imagine you also have a point related to this.
Yes, and another, yeah, actually for the workflow, just downloading everything to the local or user directory, data binder, ServiceX data binder is much easier. Yeah, package can run basically all those 4 requests asynchronously. So yeah, it should basically accelerate all the all time. But actually, I have a question on the delivered ServiceX delivered URL. So whenever you run coffee processor, basically you need to download files again from the ServiceX backend, or it's locally cached.
Well, in this case, they're cached somewhere else. You can download them locally too, and then access them from there. But in all of those cases, you just only need to run it once.
So I guess just to clarify, so when you're doing the run, they don't actually get downloaded to the notebook. They stay up on MinIO, and all we're getting is just the URLs to it.
Exactly.
And so they are getting downloaded to each coffee processor when they want to work on that file. So it only gets downloaded once.
Yeah. I guess this is what this output here shows. These ugly looking things point to.
That means, I mean, if you want to add a histogram, I mean, or if you want to see another distribution, you need to download them again, right?
You don't download, like you directly read them out of where they are stored.
So think of it.
Okay.
The way I think about this is when you're in an analysis facility, that means all your resources are local. So you have an incredibly high interconnect. So reading straight out of MinIO or S3 on Ceph or wherever is going to be blindingly fast, and there's no need to download it.
Mm-hmm.
If you're trying to do something on your laptop, which is at the end of your home connection, and you're going to get the data, some small data down, and then you want to start doing lots of experimentation, then it's probably very much worth it to download the data locally. But while you're all inside the nice, comfy, warm environments of an analysis facility, I would say you make maximal use of that infrastructure, and one of that is this super high speed networking.
But even then, I mean, once you download them, you have them. I mean,
yes.
If you want to make another histogram, as long as that information is in the files, you don't need to run anything again.
Yeah. Because I'm basically doing similar practice for my analysis, and the delivered data in my case is something like 250 gigabyte. And when I did that to coffea-casa, it's fine. I mean, if I run everything in asynchronously, but if I copy or if I deliver to our university machine at UT Austin, it's not so. I mean, it takes some time. So yeah, maybe that's the difference. But yeah.
So I'd really be interested to know if it takes time. So the download will clearly take time because the bandwidth between, I don't know if you're running on Chicago, but let's say Chicago and your university is probably not as good as inside the analysis facility. But once you have the data locally, it would be interesting to know if that was faster than running in across the network when you're inside the analysis facility. But that's not,
Maybe just one last thing that I kind of forgot to mention, but it is important, is that all of this functionality can also be done asynchronously. I just made it synchronously here because for a small example like this, it's much easier to follow. But the equivalent of this function exists, like I said, also for Parquet files and also for asynchronous operations.
So just briefly, I'm wondering about, is it because of some issues in the front end that you're like generating that query and then calling ds get root files with passing the query in. That seems not as clean as just like doing the selects and saying give me the root files. Is that just to work around a bug?
So you're talking. Sorry, Tal.
No. I mean, this is sort of how I agree. It's not very intuitive, at least, and maybe This is one of the sort of unintuitive things that I was talking about.
ServiceX, this group thing that we were just mentioning would go a long way to solving this particular problem.
I think this is also something we can talk. I mean, Kyunghyun has already experience from the data binder API, so that's like I think the conversation would be great to have with everyone.
Yep.
All right.
But thank you so much, Tal.
Indeed. Thanks for this demo. Thanks for everything that happened behind the scenes that was not visible in this demo, like that made that possible. Let's move on then to our next contribution here to not fall too far behind. And will continue with Jayjeet, showing us Apache Iceberg for management of HEP data. Can you share on your end?
Yeah, one second.
All right, we can see. Perhaps zoom in once or twice, and then we should be good to go.
Okay. So yeah, hi everyone. So today I will be showing a demo on how to use lakehousing technologies for managing HEP data. So first, what was the motivation behind doing this is that, for example, in the analysis facility setup, what we need to do is that we need to first ingest the data from ServiceX into S3 or SafeFS, like a file system, and then to be able to like do database operations on that, we need to again ingest it into some database like BigQuery, Athena, or Presto, something like that. But the problem there is that doing such a complex ETL route adds a lot of management over it, and especially when the data sets are like so much bigger in size and they are constantly updating. And yeah, so basically there's a risk of data falling, like data becoming backdated and stuff like that. So to be able to solve that, what we believe is that once the data is present in the file system, like in the cloud file system, it does not really it's not required to move it anymore. We can just perform all the management operations that we need right there. So that's where lake housing systems come in. So here we are using Apache Iceberg, which is a table specification, and it's basically a library for multiple data processing systems. And in this case, I am using Spark as our candidate data processing system. And Apache Iceberg adds several nice features on top of Spark, like transactions, supports partitioning, then schema evolution, time travel and rollbacks, and like allows you to use SQL and also views. So yeah, so with all this, you get like a database experience, but without you actually using our actual database. So without any overhead. Without any overhead.
Jayjeet, can I quickly interrupt? So I think that just to close the loop here, I think that the key motivation here for data management and HEP data is that you can manage essentially one data set, and you don't have to copy things in order to do sort of operations that databases can do, right? But you don't have to actually use a database to do these operations. It's basically package files plus some metadata. And that's the beauty of this new lakehouse or fairhouse systems that are emerging. Apache Iceberg is one of them.
Mm-hmm. Thanks. Yeah, so starting the demo. So let's assume we have a Spark installation already. Then to add Iceberg, we just need to copy the Spark Iceberg Spark jar file into the Spark jars as dependencies, and then we just need to add some configurations where the Spark catalog and the extensions need to be updated to use Iceberg. So mostly the first four, or like the first two configuration that is really required to be able to use Iceberg with Spark. And then we should have Spark ready with Iceberg support. Now, we have a Parquet file that we have ingested from ServiceX, let's say, and it's in SafeFS. So we now need to create an Iceberg table out of this Parquet file so that we can actually reap the benefits of lake housing. So yeah, so it's very easy. We just read the Parquet file into a data frame, and we create Iceberg table, a very simple syntax. And in this case, I am partitioning the data by event. So there are, the data is grouped by multiple events. So in this case, I'm just partitioning the data by events. And this is just, I am just taking a subset of the data for this demo. Otherwise, like the updates take a little bit of more time. So yeah, so now at this point, we have an Iceberg table that contains all the HEP data, and it's partitioned by event. Now I want to show like the features that we have one by one. So as Carlos mentioned, in Iceberg, we have the data accompanied with, which is the most important thing, is metadata. So we will just explore our Iceberg table very quickly. So when we write an Iceberg table, we have data files. These are Parquet files that Iceberg internally generates. And so we have we are partitioned by event. So for our three partitions, we have like three Parquet files here. Then we have metadata files. Then we have a write-ahead log, which basically allows doing all the transactions. So right now we are just at version 1 because we just created a brand new table. And we have some snapshot files. So the snapshot feature of Iceberg allows us to roll back and time travel, which I'm gonna show next. So yeah, so basically all these files is what facilitates Iceberg tables. Yeah, so coming to feature number 1, which is schema evolution. So Iceberg allows changing the schema, like adding, dropping, renaming, updating the columns of a table very fast with just metadata operations, and not it does not need to rewrite any of the actual data files. So changing the schema is like a really fast operation, and it does not severely affect any data. So we would just first check the schema of our table that we have. So yeah, this is the schema. Now we are like adding a new column. So we just added a new column. So otherwise, in traditional databases, when you add a new column, all the data is copied, and it takes a little bit of time. But here it's instantaneous because we are just doing a metadata entry. So when we see the schema again, we see that we have a new column called my column that we just added here. And since like changing the schema or evolving the schema is just a metadata operation, it does not create any snapshot because there is no like danger of like or like tampering the data severely. So yeah, so the snapshot is the one that we had from the beginning. It didn't create any new snapshot. And you can see that although adding a column was just a metadata operation, when we query, our new column appears seamlessly. Yeah, so that was schema evolution. Now talking of snapshots. So snapshots are only created when the actual data of the table changes. So in this case, I am updating my table so that the run field of my table becomes twice of it, just a random update. So since we updated the data, a new snapshot is created. You can see like there was only one earlier. Now there is there was only one earlier. Now there is 2. So I will do a couple more updates. So here I just increment the event field by 1, and you can see this is like the updated version of the table. So yeah, I will show you the original version when we roll back to the original version. So then you can like see the difference. So in this way, like Iceberg helps keep track of the changes that we make to our table using snapshots. Now we are going to do some time travel. So for that, so basically, since Iceberg stores the different snapshots of changes done to the table, we can use any version of the table we want, and we can also like set our table to any particular version. So kind of like Git. So we will first check the history of changes done to our table. So the first entry is for creating. Yeah. Okay. So the first entry is just for creating a table. Creating the table. The second entry is when we did run equals to run into two, and the third entry is when we did event equals to event plus one. So three changes, 3 entries in our history. Now we are going to roll back to the first version. So here I am just rolling back to the first version, and we already rolled back, and now we will see how we roll back. So yeah, this is the initial version of the table that we had. We rolled back to it. So although we have rolled back to the initial version, it's not that we cannot use the later versions anymore. So this is our history. Let's say I'm going to use the second snapshot, like the second version. So I'm just going to query, like select fields from table version as of a snapshot. So yeah, so I get the middle ground of the data. So like when I just did run equals to run into 2. In this way, we can do like all sorts of time travel and schema evolution and rollbacks in Iceberg. So now we are interested in looking in seeing if we can run some actual HEP queries that we actually care about. So for this, I am using the ADL benchmarks that were presented in the paper. The evaluating query in this paper by ETH. So it proposes a standard set of benchmarks, like a set of 8 benchmarks for evaluating query engine performance over HEP data. So if you're not aware of it, you can just visit this link and check. So yeah, for this, I'm just using a very simple one, that is the query one, and I guess the most complex one, the query 8. So yeah, as you can see, like with Iceberg and Spark, complex SQL syntax, everything works seamlessly out of the box. And we can also like sprinkle time travel into this if we want. Now I'm going to talk a little bit about partition pruning and how like Iceberg maintains partitions. So as I told earlier, like when we created the table, Iceberg split like partition the data by event. So I would just take you back to the can you see this screen, the new screen?
Yes.
Yeah. So yeah, so since we partition the data by event, as you can see, we have our data partitioned by event. Every event has a particular Parquet file of its own. Now you might say like earlier when I showed you there was only 3 events, but now there are multiple because as you might remember we updated the events by doing a +1. So that's why we have like the events are like there are like 6 events now in place of 3. Since Iceberg can maintain Hive-style partitions like transparently, we can speed up queries by doing partition pruning. For this demo, I just have a single file, so can't show any actual speed up. For that, we need a huge data set. But with just for the sake of functionality, we can apply a predicate in the query, and it will and Iceberg will detect if there is a partition, then it will do the partition pruning transparently and provide speed up. So yeah, I am partitioning. I am pruning by this event, the 173 event. But next, let's say I am pruning by the 174 event. But so you can see that there is also like a 174 event here. But why is it showing none? Because it's not tracked in the metadata files. It's not in the current version of our table, which is the actual initial version. So although the data for it exists, the metadata does not point to it, so we cannot query it. And yeah, that's how partition pruning works, like seamlessly with snapshots and time travel. And also the last thing that is important of Iceberg is views. But unfortunately, what I found out was, although Iceberg has a view specification in place, it's yet to be implemented. So yeah, if you want to follow its development, you can check out this issue. There is an update a couple of weeks back. So they are still working on it. And so unfortunately, Iceberg does not yet support views over Spark. And yeah, so I think, so after like checking all these features of Iceberg, we can safely assume that Spark and Iceberg setup is quite enough to actually perform most of the data management requirements of HEP. And unless highly required, we do not need to like adopt special systems like Presto, BigQuery, Athena. And that way we can save like data copies and data movement and just save more time and gain performance out of this. Yeah, that was my demo for today. If you have any questions, please. Thank you.
Thank you very much, Jayjeet. I find it particularly interesting to think about this time travel functionality and like what we could get out of this, because I feel like this is not something that we have access to, and consequently, like I don't think about, at least in what I'm doing. Do we have questions and comments?
I guess one comment is, you know, the nearest thing here is in root land is a friend tree, being able to actually join an entire new column. It would actually be, it'd be an interesting demo maybe for next time to show exactly that, where you take a million events and join in a column of another million events that you create.
Okay, yeah.
Because I mean, some of these things are interesting, but a bit not nonsensical, like changing event numbers or something like that. I mean, you wouldn't ever want to change event data. You'd want to augment with another column.
Yeah, yeah, you would.
Yeah.
I mean, you could imagine having electrons updating the calibration.
Yeah, right.
And not wanting to have to refer to a different column for every different electron calibration. So
I mean, I guess if you actually had time travel working, you might overwrite old things as long as you knew you could come back.
Yeah.
But still, you wouldn't change the event number.
No, but it's, you know, yeah. You can abstract that. But yeah, agreed.
So yeah, changes columns at a time would be really interesting to see.
So one question I had, I just couldn't tell. Does it support irregular arrays? I mean, looking through some of the documentation, they all talk about square arrays, like, you know, pandas data frame like objects. Whereas we of course need a slightly more sophisticated data shape. Does it support that?
So it supports lists as a data type, as a field type. So the list size can be different for every record. But I don't think it supports anything complex than that.
Okay.
One thing I was wondering with these updates that then allow you to travel back and forth, the examples you've shown is you take the existing table and you modify some of those columns in there. Can I it also essentially like a new table, which is, for example, because now I did another query and I got some new files, which mostly might have the same events, but perhaps I changed something in my initial selection that went into those files. And can I treat all of that transparently as like one big table now that I can like walk through back and forth? So it's essentially, as I sort of develop my physics analysis, where some of the things might change, which then leads to changes in all the rows and columns, instead of having to treat everything as like a separate table, can I join all of that together? So like I can go back and forth?
Yeah, so Iceberg allows exactly that. So like adding more files to the table. So if you have got more files coming in, you can just use the add files function of Iceberg to keep adding files to the table, and it will just transparently treat the new set of files as the updated table, and it would then create snapshots out of that.
And I can remove as well, presumably, files from the table? Yeah, okay. Yeah. Right, so I could evolve it as I rerun my analysis, for example. Okay. Thanks.
Yeah, as long as the data is changing, you can snap. Yeah, thank you.
Other questions and comments for Jayjeet? All right, I don't think we have anything else now. There's some more comments as well on the Google Doc. Then thank you very much again. And I think this like joining idea is interesting, because I'm assuming the performance for joins here is like super good, because people need that in practice, right? So it's probably like a good example to show. All right, then perfect. We already have Matthew up next, who will show AGC at BNL. Please go ahead.
Okay, and also, can people hear me through this mic? Or
I can hear just fine.
Yeah, but can people on Zoom hear me through the mic?
Yeah, I can hear you.
Yeah, you're great.
Okay. I just didn't want to accidentally induce a bunch of echo. Okay, great. So today I'm going to be giving kind of a short overview about my experience with trying to get the AGC pipelines working at the BNL analysis facility. So I'm not going to go into full screen, because I'm going to be kind of jumping around between some slides as well as notebooks today. So on slide 2, first I just want to say that like really everything that I'm showing is thanks to the really nice work of the BNL team. So a big thanks in advance to Doug, Offer, and Chris. They've been extremely helpful when I want to try and do something. They've been making that quite easy. So far, this is really just kind of a showing of the first unoptimized steps of me literally just grabbing the AGC analyses from GitHub and then just trying to run them. And all these are being run on BNL's Jupyter instance. On slide 2, so one thing about the BNL Jupyter instance that's different from the other analysis facilities is that BNL has this SDCC Jupyter launcher, which allows you to define custom images if you want, that can be run as singularity containers. And that means you can pull from either public image registries, or what's I think generally preferred is that you pull from CVMFS unpacked. So given this, what I've done is I've made this kind of development image, which is on the analysis or the IRIS-HEP GitHub organization. And in this basically tries to include all the libraries that we would need, as well as additional supporting software to be able to run the analysis grand challenge. What's kind of also nice about this is since it's user controlled, we're able to, if we want to try and very quickly update something and iterate to try and see if the bleeding edge releases of some of our release candidates work with things, we can also have a very short build time on all this. And these images are hosted on the OSG Harbor under the IRIS-HEP org. And so a big thanks to Brian for making that happen and being really helpful with just getting things going there. As I also mentioned, this is something that is controlled by us at the moment, and something that I've been trying to do is make sure that as much of the image is actually built from lock files as possible, because this makes the dependencies in it extremely well specified. And then also, since they're being defined down to the hash level, it's very clear what needs to get installed. And so this also makes in the long run, rebuilds incredibly fast, because now instead of having to do any sort of environmental solves when you're trying to actually build the image, you basically are just giving it a list of URLs to then pull down from. So I basically noticed that the build speed to kind of rebuild this image in full is mostly limited by, if you need to actually update some of your dependencies, is mostly limited by how fast your internet connection is. So this is kind of a nice turnaround time for testing. And then this also allows us to be able to just go ahead and, since these images are also synced to CVMFS using CVMFS Unpacked and Sync, that means you can also just go ahead and pull them and go ahead and drop into drop them and go ahead and pull them and drop into them. This is loading right now. So what I'll mention is, well, that's coming up. I think it already is. Oh, sorry, I need to move the share options. I stopped sharing accidentally. Let me try and move these Zoom controls out of the way so that it doesn't happen again. Okay, yeah, so this is coming up, and you can see that I right now have this analysis systems kernel that's being detected, which basically is the exact custom user-defined virtual environment that we had. One just kind of general note, if you're going to try something like this as well, is at the moment, there needs to be some additional work between us and the BNL team to try and figure out some sort of scheme for being able to automatically detect custom kernels from user-defined virtual environments, because if you just kind of were to drop in without doing a little bit of modulation, then you would see these default kernels, but you wouldn't see your own. But on slide 7, something that I've kind of found is a very short-term hack is to just go ahead and kind of populate a kernels directory or create a kernels directory that is viewable by the Singularity runtime, and then just to symbolically link in the actual kernels from the user-defined virtual environment to there. And once you do that, then the kernel pops right up and is actually usable, which is nice. So that way, if you want to be able to ensure that everything that you're doing is using the exact dependencies that you've defined, then you can do that. Okay, so as I mentioned, what I've been doing so far is I've just been running the exact sort of the AGC analyses that are up on GitHub with as minimal of changes as possible. To try and make things more efficient and more realistic, Doug has also gone ahead and moved data that's used for the CMS Open TT-bar analysis to BNL to make that available. And kind of the nice thing right now is that we've already been able to very quickly show that, maybe I can bump this to, this doesn't want to become bigger. Okay, there we go. Yeah, we've been able to very quickly show that the entire notebook can run end to end. So I'll maybe go ahead and just get an example of that for a very small amount of data running right now, and then flip back. So this is a nice start, but since BNL is different from the other analysis facilities in the sense that it doesn't use Kubernetes, and so it's not a coffea-casa instance, I have to change the global config a little bit. So I'm running the pipeline settings with just a pure coffee setup, and then we are able to use Dask, which is nice. But then just for the actual analysis facility type, this says local. This can maybe be optimized later with some additional work, but this is just currently just trying to use Dask distributed instead of trying to actually use coffea-casa resources. And then the fork that I'm running on, I've also just set the analysis facility name to BNL to actually try and look for the data that Doug has already moved over there for us. And so if I go ahead and actually, the bottleneck or the thing that causes for the CMS open data is that where you're actually running the most and actually doing the compute is this data delivery pipeline step. And so these are just kind of the run times for that I've cherry picked for there's these, here there's this basically summary table of these number of files per sample that are being run, and that basically gives you the total size. And so I've run this at BNL now for 157, 678 gigs, and a terabyte. And we can see that so far these numbers aren't like, well, these numbers as themselves are maybe not super useful because I just in the abstract, and at the moment another thing that we're working to get up and running is better kind of monitoring with Dask to actually be able to see how your scaling is going. But for a unfair comparison that I don't think and let me stress, this should not be a one-to-one, because since at the moment I'm not sure how the scaling is actually being done in the Dask backend. I'm not actually sure how I'm comparing the resources between BNL and Chicago. But so you can see that at the moment, the scaling, the total run times as you go up in data size is not really tracking at BNL comparatively with UChicago. But I think what this means is that I don't really understand how scaling is done, and so we need to do some additional work just to make sure that the resources which BNL has and should be able to handle this are just actually getting properly picked up.
You're scaling on one VM with 6 logical cores. 16, sorry. 16.
Sorry,
so the most you could do is 16 cores at once.
Okay. Okay, yeah. So, well, that already helps give some context. All right, so, but I was just gonna, so that's really all I have, other than to just say that things are actually, it's nice that with just a very minimal amount of work, things were able to kind of just drop in and go at BNL. And so I think right now the main kind of question is how to understand scaling better and how to make sure that we can actually have the Dask dashboards working. So for example, right now, the way that I have Dask set up in the container, it doesn't seem to be able to detect the clusters. So this might be because I'm missing software, or it might be, or there might be some other issue. But I think once we're able to add this support in, this will also make it easier just to, at runtime, to be able to try and monitor things. But yeah, so there's going to be a little bit of work, but I think overall this is pretty optimistic.
I would say there's always a lot of work behind anything that looks like it has a minimal amount of work. So a quick question maybe for Doug on the BNL side. What do you envision the scale out mechanism to look like? Whether it exists or not, what are you thinking?
Well, we hope to submit into the shared pool. I mean, that's our plan. There will be, that's essentially our large Condor pool used by US Atlas Tier 3, the neutrino experiments, and other users. Of course, because it's a shared resource, occasionally gets full.
Yeah,
that's not great for people who want interactive scale response.
On the other hand, that's a fact of life for people who want to scale and not pay for it. We run into the same thing with benchmarking at Nebraska. It's, if you want realistic, part of life is sitting in the batch queue for more resources, which makes it hard to be reproducible.
Yeah, and all this data is sitting on a Lustre instance with 3 JBOD servers of 102 disks each, I think. So the JBODs are capable of 6 gigabytes a second for writes each. So anything that was going through this was going through the Lustre client.
One thing as you get to scaling up doing the Condor integration. To my knowledge, Matt at Wisconsin, Ben Jones at CERN, and Oksana at Nebraska have all written various Condor.
Elastic facility.
Yeah.
Right. The thing that makes ours a little different, which is a slight challenge, is handling that arbitrary container that the user passes in.
No, I'm just saying that I think it would be useful to make sure that all these folks talk to each other, and there might be even a dream to. I don't think there's going to be one integration to rule them all, because these are all fundamentally different. But I was suggesting maybe you could put them at least in the same Git repo, or something.
This feels like a topic for the HSF Analysis Facility Forum to get everyone who worked on this to share their views, perhaps.
Yeah, because I bet we could probably find another 2 or 3 of these.
This is more at the service side, so I think it's closer towards a WLCG type of thing, to be honest.
Yeah.
Because it's data center, but we are starting to do this anyway. With impromptu conversations between Fanal and BNL, and then we also BNL talk with Oksana, but formalizing it more from more of a data center side would be useful.
Yep.
So would I take your comment to mean that you don't really support putting this in a Git repository?
Oh no, we should, anything that's not business sensitive should go into a public repo and you know, documentation and anything, so we can help others. Absolutely.
Yeah. Okay, because you mentioned WLCG, but to my knowledge, WLCG doesn't really specify any repository. And yes, we're all collaborating on Ruscio, but I think right now it's still hosted out of the CERN repo. And I don't know, I would think something like this could go into GitHub.
Yeah, I'm not suggesting that it doesn't. Just anything that security related shouldn't go in.
Of course, no, the secrets, stay in a vault.
Should be secret.
Well, but also things that we should look at when you put stuff in, because I've been looking at some of the things in the repos are IP addresses that are.
No, that's bad. Yeah. Mm-hmm. Yeah.
Okay. Any other questions and comments for Matthew's talk? And thank you very much for making this work. Again, it's the type of thing where there's like lots of work behind the scenes, which is totally not obvious to to get here where the notebook just runs. So thank you very much for that. Anything else? If not, then I think we will move on to our last contribution from today, which is JWT tokens to access XCache at coffea-casa. I don't know who starts this contribution, Oksana?
I think Carol sharing the first part integration, and then Andrew is running a mini demo just to show it works or not.
All right, are you going to share on your end? Carl, I guess?
Yep. So I was asked, in order to facilitate things, to describe the life cycle of a token in our setup. And hopefully, when you actually use the software, the token is actually transparent to the user. That's the whole idea behind using the tokens. And getting away from X509 is we want to be able to see or not manage the authentication at the user level. We want the system to actually handle that for us. So what happens in the user experience is the user logs into the browser at coffea-casa. At that point, it contacts the IAM server at CERN, makes sure that you're a CMS user, and returns 2 things. Returns an access token and a refresh token. The access token there has a lifetime of about 6 hours. That's configurable at the IAM level by the IAM czar, not by us. That access token and refresh token are then taken by coffea-casa And the refresh token is stored inside Jupyter Hub's container in an SQLite database. And so it's kept away from the hands of the user because the refresh token is actually quite permissive and powerful. The access token is then written down to a Kubernetes secret, which is accessible by all the containers. However, once it's accessible by the containers, it's not usable yet. It's not usable because the permissions and the ownership aren't correct for the token. If you've ever used your certificate with gfile copy, it checks the permissions of your X509. XRoot D does the same thing for the access token. It's going to check the permissions to make sure it's not too permissive. It's going to check the ownership to make sure that you're the owner of that token. And so we have to change the ownership and permissions of the token. To do that, we constructed a sidecar. The sidecar then grabs the token, copies it to a new file, changes the permissions and the ownership so that the bearer token is now usable inside the instance. The user then takes that access token and makes a simple query to the XCache server that we run inside of Kubernetes. That access token allows then the reading from the data. That access token is shared to the XCache service, but via TLS. We had to construct internal CA. We used the certificate manager that's already available in Kubernetes to do this, but we established an internal CA so that the TLS can happen and the access token is securely sent over to XCache. XCache then is allowed to access remote data either via XCache using an X509 proxy that's dedicated to the XCache service, or it can pass that token on further down the line. The trouble is the vast majority of the XCache or the XRoot D servers in CMS don't honor tokens yet, and so we have to have this X509 proxy sitting on the XCache service that's registered as a CMS user to read the data. Like I said, the access token lifetime is about 6 hours. It's renewed every 4. The sidecar makes sure that the renewed token's refreshed and the ownership's correct. But all this should be transparent to the user.
Where does the sidecar run? I don't see it on your diagram.
Yeah, I should have put the sidecar on the diagram. The sidecar runs just inside the single user pod.
Okay.
So it runs alongside the notebook.
And one hope is that the XRD folks would give us a way to relax this, so having a container that does nothing but copying a file every 2 hours feels a bit excessive to us.
We have exactly that container sitting inside of ServiceX.
Yeah. I think a lot of people have re-implemented the same thing that the XRD folks could just. Anyhow, so the point of the sidecar is to not be there 6 months.
Andrew, are you ready?
Yeah, let me see. Can you guys hear me?
Yep.
Okay. I think I want to share this screen. Okay, yeah, sorry, I'm not quite as savvy with notebooks. I probably should have put this example in a Jupyter notebook, but it's kind of going to just be, it's just a short example, so it shouldn't be too bad. So I'm kind of just going to start from like the beginning here, just logging in, kind of showing, what Carl was talking about. So if I just sign on with my CERN credentials, and also since this is the last demo of the day, and all the other ones went perfectly, that means mine's gonna go horribly.
No worries.
And it's off to a good start. It doesn't seem like it wants to log in.
Try clicking again.
Well, there we go. It just had the. Okay, so this is basically the IMA thing where basically I gave it permission, and I've been tacitly asking it to prompt me every time so that I could showcase this in the demo. Where basically I authorized it.
An important line in there is the one that says read access to CMS data. There's a list of all the things it gets. And
yeah, so anyway, so yeah, so then I authorize this. And then after that, I'm logged in, and then I can start up my coffea-casa instance or server. This shouldn't take too terribly long. And then, yeah, and then I was gonna basically just kind of showcase a just a couple of examples here. So I guess, yeah, to begin with, I guess I think one thing to mention was that, like, so the access token, like was mentioned, is copied to this area, and it's following, I guess, this WLCG bearer token discovery specification. So I guess that's kind of following a standard there. And so at this point, the user doesn't really have to do anything. Like they don't have to like do a VOMS proxy. They don't have to worry about constantly making sure that their VOMS proxy is up to date. That's kind of all been handled behind the scenes. And then, so for example, I can try to copy this file using XCache, and hopefully it works. And so basically, yeah, it's copying this file through XCache. I should notice, like the first time through, it's going, at a reasonable clip, not too terribly fast. And that's because it's copying it from the actual source. But then if I were to, for example, do it a second time, this file is actually being cached. And so now it's like blazingly fast. So this is kind of one of the benefits of using the XCache. And I guess, like, as an example here, if I were to use not XCache, like if I was just use the regular old UNL redirector, it goes reasonably fast here, but still nowhere near the speed of the XCache server. And also, if I do it a second time, right, it's not actually being like cached in the same way. So repeat accesses to the same file isn't gonna really speed up too terribly much.
And it's worth pointing out that when you talk to the UNL server there, that's talking to the tier 2 with a token, which that tier 2 does, but that's not going to work everywhere.
Yeah, so I think I tried this out with, like, I tried to use the Notre Dame redirector, and then yeah, that basically just hangs. It times out because it doesn't ever get a valid response. So yeah, so I guess. Go ahead.
I want a tiny remark that even if you see that it is AGC data, through XCache it require a valid proxy. So here, I mean, it's kind of tricky because you see AGC and you suppose that it is open data, but only through, if you access it through HTTPS, it is public. But like this, you could try on your favorite facility and you will see that it will tell, please have valid proxy, permission denied.
Yeah, I mean, and I can also, for example, I mean, this is CMS, run to data. I just didn't want to use this because it's not the individual file is not as large, so it goes by really fast. So getting like an accurate timing is not as easy. But yeah, so this was just kind of like showcasing, like kind of doing it, doing an XRDC, by hand, from a terminal. But then also, I also kind of just hijacked the CMS open data TT-var, same analysis that was showcased in the previous demo actually, and essentially I made I changed this to the only change I made is so on this line I changed it to actually use the root XCache system, and then down here I changed use XCache to true, so the whole thing will use the actual we'll actually be using XCache. So let's see if I try to run it here. Basically just going to try and see if it actually runs. Fingers crossed. Also, since I'm on, I think the development instance here at coffea-casa, I don't actually have access to, I only have, we don't have, the full scale ability. So I'm only running over five files here. Okay, and it is, it might have already, okay, yeah, so it's running here, right? So, if I go to my dashboard, right, I mean, this is kind of all, people probably have all seen this type of stuff before. It's processing the data, and oh, actually, I should have mentioned this. This is all going through Dask, of course. But yeah, so it's running. Like I said, right now I only have the one worker, but that's because I'm on this development instance. If I was on the production instance, this would scale up quite well. Of course, depending on how many other users are currently on the system at the time, and the more cores you have, the faster it can run. So yeah, I think that was kind of all I wanted to show. It was just kind of an example showing XCache, using the XCache stuff is actually working. So yeah, then it produces all these nice, impressive looking plots, and you get, an entire analysis all in a single, Jupyter notebook.
So yeah, super great. I'm happy that it worked, even though scaling, next time we will do a bit more complex test. The thing is that, so we use this model of accessing data on CMS coffea-casa, and it's something missing on Atlas coffea-casa. This is something I want to also to introduce, to probably test with Fengping and India, to try to make also XCache at UChicago to work with the tokens that we generate through Atlas EM instance, because both facilities are basically mirrored. And that would be very useful, because then it will enable Atlas physicists to access Atlas specific.
That would be absolutely wonderful. Is the Atlas X509 infrastructure the same as CMS? I mean, is it by definition because it's X509?
We yesterday saw Alex showed us how looks Atlas coffea-casa, and it's absolutely identical. So.
What credentials actually being used for the proxy to pull when it's not in your local site?
Some guy named Carl.
Very few storage use. I mean, this is excellent that you're using tokens for storage. It's the first time.
We're using Carl one, but it's the same concept that is actually you see behind ServiceX. So actually, ServiceX is running from Ilya proxy, I think, in this case.
It's changed a couple of
times.
Yeah,
we're waiting next year.
It's a single proxy.
I know, but
So one thing that I'm hopeful for is the CMS SAM tests are changing to test token acceptance. Obviously, they won't be critical for some time, but it'll at least allow us to survey, and it'll count from 1 to 50 as people progress. The other one that I thought that was interesting is talking to the EOS guys here today. They thought that they could turn on the lights for EOS CMS in January for tokens.
Wow.
That would be an interesting one, because that would mean when it talks to EOS, you could say if you have your own personal data on EOS that Carl's proxy is not authenticated with, the token would go through. So I think we set our next demo day in late February, so that would be one of my big goals, to show EOCMS data based on tokens that, you know, some guy named Carl's proxy cannot access.
Yeah.
Right, and I guess you know, like kind of like part of this. I mean, I'm not super familiar with this, but I mean, as far as like, and this is all like kind of like reading data, right? But like the token access should also allow you to like write data, correct? Like to
write, yeah.
Which obviously, you know, if you're going through Carl's proxy and you want to write to your own area, he's probably not going to have write access to an area that is, you know, assigned to someone else, right? So
we have a lot of things we want to do for the February. I'm not sure all of it will make it, but that would be another.
It will be a demo week instead of JavaScript.
How CMS specific is this? Because you're saying EOCMS. What about like the Atlas story? Is that going to be way different? Or?
They said somebody just needs to ask.
Yeah.
I mean, they have these on they have these on the test instances, but they just kind of said.
So this was actually going to generate a question, which was to Doug. Who is the person that deals with this sort of thing inside of Atlas?
It would be Mario and Sean would be the DDM coordinators who would reach out.
Okay. Perfect.
At least for the storage part, whether or not, I mean, I'm not sure if Atlas has a test instance of the AIM infrastructure or not. I know there's a WLCG test infrastructure that can issue tokens.
Yeah, so there's an Atlas instance. Peter Volkish would be the person to talk to, and you know, we have to make sure that, say, he's thought about who's allowed to get write tokens into where, right? So he might not actually enable some of those scopes.
We can't do the write tokens yet because we'll be writing into pledge storage, so not going to happen anytime soon until it's really worked out.
Exactly, that's my point.
But read tokens, even just getting read tokens is a major lift.
Yeah.
So could the people who set up their XCache to make it token friendly, can you share around your instructions so that other places can enjoy the fun?
Yeah.
Okay, thanks a lot, Carl and Andrew, for this demo. Any other questions or like comments specifically to this? Otherwise, we do have some space and time scheduled here for the rest of this meeting where we can talk about other more broader topics. And one thing that may also be of interest is like prioritizing the next steps, what we want to do on like a 2-month timescale. Perhaps we do that last, and then if there's other sort of broader topics that came out here that I'd like to focus a bit on more, then we can go through those.
Did we get anything in the Google Doc that we didn't bring up already?
I think we mostly like addressed things in there, but feel free to bring something up if you wrote something in here that you would like to discuss more broadly.
I added a comment. There was this little discussion that we had about, you know, making well, Alex, you said, for example, you can have a ServiceX data set group. In the beginning, we were talking about, you know, grouping all your requests in one for every single file, and not one for every specific data set. I just added, you know, for efficiency's sake, yeah, of course, these kinds of things would be good to implement, but I don't, from the analyzer's point of view, I don't think necessarily making something shorter or nicer looking on the surface is always better, because you know, as for the analyzer, it's very important to know exactly what is going on, especially when something is super complex and sort of hiding stuff, even though it might look really nice from the development point of view, is very often quite suboptimal, I think, especially when you start dealing with really, really, really complex stuff where you have to absolutely make sure that you know everything to super precise detail, because otherwise, you know, you can't trust your results. And I don't know, I thought I'd bring this up. I mean, it's, you know, this applies to this specific thing where, okay, you know, efficiency is good to optimize, of course, but making stuff shorter, not necessarily. Of course, this goes for all of the, you know, anything that an analyzer might have to interact with, that we are now sort of setting the stage for, to keep in mind that shorter isn't always better, or nicer isn't always better.
I guess by providing the interface, you're not forcing the user to adopt it. Like, you could have different levels and layers at which the user can like go in and use whatever seems suitable to them. Yeah. The only question is, of course, if by providing it and sort of showcasing things, people assume that that's the way to do it and like don't know about other options.
You can very easily imagine a scenario where someone looks through an example where a sort of more simple use case is shown, starts from there, building their analysis, and is unaware of the, you know, deeper, more detailed function.
A way to look at it is, if you look at what's in there now, you can spot some things like, you know, return castle equals true, which is just nonsensical from the point of view of, I mean, technically it makes sense, but it's nonsensical from the point of view of somebody who's, you know, just wants to get some physics columns of data out. And so that says something is wrong with the current interface. Maybe the group isn't exactly the right way to solve it. Maybe there's another way. You know, Camille has solved it a similar but different way. You know, maybe there's a different way to solve it, but something should be. Something should be fixed.
Yeah, I mean, but that's sort of it's somewhat related, but it's somewhat separate too, right? I mean, sure, we want the sort of overall workflow to be intuitive, like when you do some operation and you have no idea what it does, but you know that it's somehow necessary. Yeah, that's not very intuitive. But also, you know, when you run a step that you know does multiple different steps behind the scenes, then sometimes it's good to know.
You could imagine if you had a grouped data set with 20 data sets and you made an error in your query, so you asked for something that didn't exist, you would now get an explosion of errors because everything would be multiplied by 20. Which actually reminds me, Ben, what are the chances of being able to deep link to the log files when an error comes back from ServiceX? So somebody actually, because right now the error is completely opaque, it just says I can't get the error, but you know, a link to the dashboard where someone could actually look and say, oh, I just asked for electron PT as opposed to electron PT.
So there's two approaches to this. One would be to just embrace the like the logging server, or what is it, Elasticsearch, that lets you pull logs out. So it could formulate a URL that you would just visit that would dive in there and find results from that. The other thing is with the new transformer sidecar architecture, we've got parsers that can go into the log, like into the results from an individual transform. And if we get better at figuring out how to pluck useful information out of common errors, we can set that as like the error reason for the transform, although a lot of the infrastructure for that got ripped out with the database simplification.
Why not do or just drop all the error logs into MinIO?
I mean, that's what we were doing.
And then give a link to that to the object, and people can always download the errors.
That's exactly what we were doing.
Downloading the errors is like what I have to do on the grid, essentially, right? If I want to look at things. From a UX perspective, that tiny extra step makes things a lot less convenient. Also because if you want to share it with someone briefly, they also have to download the file.
Yeah,
And
on the other hand, if the alternate is have no errors at all.
I know it's definitely a step up from.
I mean, we don't need to use MinIO because we do have them all in Elasticsearch and Kibana.
So, actually, Ben, the Elasticsearch, it occurred to me that that sort of approach may not work at a place like BNL, where you don't get a dashboard, right? Because of security restrictions on HTTP endpoints.
In reality, actually, having dashboard, it's also for other reasons. Like, for example, it's again like what is saying Alex. It's one extra click. If we could integrate it somehow and facilitate the
In facility?
Yeah. So, for example, we have like you know in dashboard you have logs. You have.
I don't know what facility is when you're using it as a noun. That's all.
In Jupyter Hub, in this case,
Oh.
is an interface.
We actually we had an IRIS-HEP fellow who built that.
So that one is.
It needs to be turned into production from a prototype. But anyway, the thing is we do need to solve the error issue. It would be great to get to the point where everybody could look at the errors somehow. So
like I said, we could. So for better or for worse, Ilya's plan with the logs is that there's only one Kibana instance at University of Chicago that rules them all. And so by default, every ServiceX instance on the planet reports its logs to the University of Chicago Kibana instance. So in theory,
Is this a planet GPTO doesn't exist? Yeah, I'd like to live on that planet.
I am pretty sure that people at BNL, their eyebrows are right now climbing up their foreheads.
It is.
WLC security people are swinging around.
I found this out because Ilya was complaining that for debugging, I deploy my own instance locally, which I call ServiceX. And he was like, what are all these messages from ServiceX? It's like they were coming out of my laptop, and I didn't realize that I was actually logging to University of Chicago. But anyway, be that as it may, if we take that as a
attack.
There is a URL. So you could formulate a URL that has the search criteria in it that says, give me back the log messages for this particular transform for this file. So
right. And that would work at some places like Chicago. But anyway, we don't need to take up all the time discussing that here, but it's something we should solve.
One thing that speaking of open endpoints, for the Triton stuff, maybe it's more of a wish for the next day, but it'd be interesting to see how Fermilab has implemented a security layer on it. I'm sure I can do some interesting Bitcoin mining with enough Triton inference servers.
So this is perhaps a topic where we can tell Lindsay and Claire about this for our topical meeting on the 18th, I think.
Yeah.
Perhaps that's like something that we can also discuss there.
Yeah. I mean, the interesting thing from facility is always, authorization. How do I control who's in and out? And resource management. If one person who's authorized decides to mine Bitcoins or whatever, or reconstruct all their jets and inference, and can they use 99.99% of the service because they just have things that run 1,000 times slower?
So Brian, are you looking for a specific answer on this right now, or you want to punt? Because I can answer this.
Yeah, and it would also be a good demo if the answer is long. But I'd be interested in like the 30-second version of how.
So the 30-second version is, so one thing we have, this isn't auth N or auth Z at all, but we do have, we put a Nginx in front to handle, so we run that just present the TLS interface. At least stuff is getting encrypted along the way. Since we did that, I think NVIDIA actually added a gRPC over SSL mode for their thing. They also have some really primitive auth that you can do with this, the standard TLS, mutual authentication, which sucks. So we haven't implemented that. The being able to put models is only available to authorized users that have Fermilab accounts. So you wouldn't be able to mine. You'd have to be pretty clever in what you do. We're also looking at this stuff, and Brian, you're probably aware of this, that Dima's written this authentication plugin that basically, it's basically a Go authentication plugin that's in front of any web app for token auth. If we looked at putting that in, I think I stalled out trying to figure out some of the token issues I was having, but that's something we're probably going to take another look at.
And then what about resource management to make sure one person doesn't drown out everybody else?
It's a pretty fair share system, so there's not much to, in terms of, yes, we're relying on sort of Kubernetes scaling and scale out, and we're auto scaling up and down. We've sliced our GPUs with multi-instance GPUs. We've got like 40 slices of the thing that we can allocate. But that's a standard resource constraint problem that I don't have any cleverer solution to than we've come up with other resources that we have constrained.
How big are your sliced GPUs?
We've got some that are 10 gigabyte. That's the A100s you can slice, I think, into 10 slices that have 10 gigabytes of GPU memory each. So we've got some with 10, but then actually we found that we were hitting out of memory issues with some of the inference. So we've got quite a lot of 20s out there.
Okay, thanks.
Alex needs like 80.
Anything else on that GPU topic and Triton access?
Lots, but I'll hold it for January.
Yeah, well, I think right. The topical meeting, I think, will be a good place to discuss this. Perhaps one direction we can move towards is what do we want to prioritize now in the short term until the next demo day in 2 months. So already we have a GitHub issue, which is, I'm not sure it's linked somewhere for that, where there's lots of ideas, and we'll drop it in the chat, or like actually in the
Was that in GitHub? Not in GitHub, in Indigo?
That is in GitHub, and it is now going to be under discussion in the Google Doc as well. And
it's number 87.
It will be cross-posted 95.
Oh, 95.
87 was the last one, I think. So yeah, this is next demo day. Already there's an extensive list of items by Brian, and perhaps Brian, you already have some idea of possible prioritizations here.
Nice.
But it might also be interesting to see whether we have like potential synergies where sort of like tackling multiple of those enables some broader strokes functionality and such that we might want to sort of group together. So perhaps, Brian, you can start with some suggestions here, or like some thoughts of what might make sense.
I mean, on the coffea-casa side, once you get now that we have the tokens there and present, then there's just a lot of different, use it with that service, use it with that service, use it with that service. So there's a big for loop of all the different things that's pretty easy to add those in. I think it's going to be just a matter of how much can we realistically do in 2 months. So we'll probably internally try to decide which one. I think so. The one thing that would be interesting that's not token related is our data frame demo. We've talked that it's called coffea-casa, but there's no thing, for example, that's really blocking you from using our data frame on any of these. So I thought like our data frame view of the world would be a really interesting demo.
Yeah, I think distributed RDF with DAS scaling on the same resources would be a good demo.
Yeah. Actually, we should split screen it. We have one do Dask with RDF and one do Dask with coffee, and you can see your resource contention. Of course, the delayed dependency manager demo.
That one is.
It's obvious.
The next one is ServiceX with. Want to make sure that it can work with tokens that we just showed that we able to generate. So idea is that I think there is already some part of infrastructure there, and we brainstormed about how to actually do step-by-step, how to integrate it. So I think that one should be so much beneficial for facilities in the terms of integration, and also it will allow us to do next step, because for example, what is happening with XCache, in some moment we want to, now we talk to XCache with the tokens, but then okay, outside there is proxy and etc. The same will be with ServiceX, because it's basically very similar service, so we want to have to use token also to talk to ServiceX, for example. But then afterward, when there will be what is more ready for the tokens, then it will be easy also to replace this single, where you're running through the everything like from the proxy of somebody, you can also use tokens there. So we start simultaneously.
So, I mean, ServiceX, you already need to use a token to access it.
Yeah.
So you're talking about using the tokens that you get from the IAM service,
Yes.
as opposed to the tokens that are auto-generated in ServiceX's infrastructure.
Yeah, so
to propagate the credentials of the user making the request, ideally in the long term, because one thing that we have now,
in the long term, great, but you know, as she points out, there's this problem is very few places can sync the tokens at the moment.
Right.
So you have to keep some sort of X509 proxy floating around, and you know, I don't think we want to duplicate the infrastructure that's already been done once.
So, very naive question. Can I make an X509 proxy out of a token?
No, but when you access it through XCache, it can set it to try the token first, and then if that doesn't work, then try X509. So the idea scenario, maybe day one, 5% of the servers actually, it passes the token all the way through, but as things progress, you know, it'll slide through.
So it's not enough for XCache to support the token. Also, the place where I get the data from through XCache needs to also support. Yeah. Okay, makes sense.
And for me, I think the really interesting one would be if we can actually get this rolling with the EOS team at CERN. Because that's one place where there's actually a lot of user level data, which a common service proxy might.
So this also came up in discussions actually with Mo, who's here.
Doug has his hand up, just so you're aware.
Yes, I am sorry. Let's Doug. Sorry, let's take you.
I would suggest that we start thinking about multiple concurrent users, because it's one thing to do one-offs. It's a whole nother thing for resource contention in places you don't expect. If you have multiple concurrent people, the step from 1 to 2 can often be a big one.
Total we had 35.
So we're 35 people on Zoom. So maybe
25 and then here.
Yeah, so 35 is a good number for, you know. So maybe we do a demo where everybody clicks on the same thing at the same time.
So if you have something in a notebook, it's extremely easy to automate it. And so you can just spawn off 30 processes, use the MB viewer with the appropriate flags to force it to actually do the calculation.
Yeah, but it is often different when you have 35 different individuals coming with different credentials, coming with different weird state in their notebook. I mean,
okay.
Yeah, we test different parts of the infrastructure. I
Grabbing different data, all this kind of stuff.
Yeah.
It's it increases the entropy greatly, which always makes it fun. Because the only other time that you get something like this is when you're doing training. And you want the students to learn and not just be
your beta testers.
Yeah, exactly.
Good points. So is that listed as one of the?
No, that's a good idea.
Not right now, I think, but we can add that. Yeah.
That would be fun.
But also, like, we have this plan that actually we want to make this as a tradition and start to do demo days each 2 months. So it doesn't mean that we need to have to do everything like.
Yeah.
So we can plan more things. That if you have ideas.
I'm just saying we have an idea which seems good. Yeah. It needs to get recorded. That's all.
I agree.
Because I certainly can't remember things if I don't write them down.
Yeah, I already see Ben is writing. Yeah, I love it, Ben.
This whole thing about Triton server, it sounds like Fermilab has a lot of things that Nebraska and others could learn and benefit from. So absolutely. Again, we're depending on priorities, that might be another interesting thing to try to get working.
What? Did you apply for Lincoln? Yes, I did.
I mean, I don't want to volunteer too much Feng for work, but some of these things also on the Atlas side as well, I think would be really useful.
Yeah, I mean, also we do have GPU resources at SSL, right, which would be available in principle, as far as I'm aware.
We are certainly in the Chicago analysis facility. I don't know if it's on the river cluster, but
all 3 of the Atlas analysis facilities have some number of GPUs.
Yeah. We are heavily using them. I've got a grad student who's trying to do some physics on it.
Yeah. Another thing for the Iceberg demo is to come back to this kind of a friend tree like merging of columns.
Yeah.
Oh, large scale joining, yeah.
I think this is not in the short term, but in the long term, we probably want to actually think of things that are more infrastructure based, which is essentially the cost of POSIX versus object store interface. So that's not for this round, obviously, because it's too short. But we should put it on the list going forward. Because if one of the goals is to make things as short as possible in terms of resource, because we deal with constrained resources.
Yeah, Nick Smith was looking at that in the context of CMS and like showed some results at ECAD, I think. And I mean, certainly we can follow up with him, but yeah, that seems like another big topic indeed.
Yeah. At one point, I know Ilya was talking about maybe doing a scaling demo, which I guess we ran out of time, but I'd be really interested to see. So I know he's been doing tons of scaling work.
So there actually I was wondering about one thing. If we do pure column extraction in ServiceX, are we ever going to get to the point where we actually are using so much CPU that we scale? My understanding was that essentially the scaling is if like you demonstrate that you're not purely IO bound, but are you ever not IO bound if you only pass through columns? Yeah. That wasn't clear to me.
Yeah, there's probably tuning left inside the scaler that ServiceX uses. There's probably some work left to do there. And this is, in fact, partly what Ilya has been working on is, working on these. I can't remember, Ben, how big his data sets get, but they're hundreds of terabytes.
Yeah, they were gigantic, yeah.
Yeah, and so, I mean, there's certainly one problem we've seen is, like, if you're sourcing a data set that's coming from Italy, you never scale because, as far as we can tell, it's so IO starved. There's no point.
But I think that would be great for a demo, just to show.
Yeah, agreed.
I mean, I've always wondered what happens when, again, somebody puts a Bitcoin miner and a ServiceX transformer. You know,
but the functionality will come, right? Like bring your transformer.
Yeah, so. not that any user would ever accidentally put a infinite loop and a function, but if such a preposterous thing happened, I'm always interested about resource management, and if Oksana writes an infinite loop and then Alex tries to submit, does
I think I'm more likely to write it than Oksana.
Are there ServiceX benchmark transforms that can be used to measure scaling?
Yes, Ilya is, at least Ben, is that right? Ilya is probably the one who's keeps those most up to date.
Yep.
And XCache makes a huge difference with these.
Right, because it's our understanding that if you're IO starved, scaling up is not a friendly thing to do. Like the Italian hosts would probably not appreciate more things trying to grab data out of them at the same time.
So I never considered this. Is there then an issue if you try to make too many requests that they can't serve you and they you DDoS that endpoint, or so that is a problem?
So the place I've really seen that problem is when I tried to run some of the TT bar analyses directly from the CERN open data. I got so data starved. It was something like one event per 30 seconds or something like that. I think they eventually just turned the tap down.
Okay.
To some extent, the easy part in these is scaling up, because that's a function of hardware, but managing
your hardware, not
it tells you how big somebody's hardware budget is, but scaling up isn't always that interesting. Showing that you can actually manage resources and not just pound the remote site into the sand or these sorts of things is what you spend 30 years studying.
Okay.
But again, I would, for 2 months from now, I'd keep it simple and just ask to see if we can do the UChicago scaling demo.
Yeah, Ilya runs those pretty consistently, so that should be something he should be ready to just do.
And I'll make sure we track that in the issue we've had in the last one, but I'm adding it to the current one as well, so that we don't forget about this.
Yeah. Well, I think he's on vacation right now. Right.
That's how you get work done, is assign it to people on vacation.
No, he was back. He was connected
earlier, yes.
I did see him briefly at the beginning of this call.
Yeah.
All right. Do we have any other bigger topics that you'd like to bring up to discuss now in this group of people here in this audience?
Also, there is something to think about, that we will have AGC execution event later. I mean, it's something 5 months later, maybe 6 months.
Yeah.
But we could start to think how to prepare various facilities for.
Yes. So it's just like there was a workshop in May of this year. If we go out 12 months, it would be May or June of 23 to try to get some people in person and have more of a community event. But because lots of things were being canceled, and this year still, the calendar is a lot more difficult. So, we might have picked a date for February, but for an in-person or larger community tutorial, we're going to do some calendaring soon. So now everybody gets really excited about doodle polls. So I'm looking forward to it.
I don't think for this we need like a particularly long event regardless. Like, I think the format for this we can make like a focused demonstration section and an independent, potentially like sort of more tutorial style thing, but they don't need to be directly connected, right? And they potentially target different audiences as well.
Yeah, and then
there's the OSG meeting. It's July, right? Maybe that's time to do it.
Yeah, it is. At a personal level, that week is both OSGL Hands meeting and Condor week. So my life starts to get a little busy.
Yeah, there'll be more bandwidth.
But something along those lines.
If the dinner is at 8, we should probably start wrapping.
I have questions about pizza.
Well, like we will be like it's close. We will be fine getting there. But yes, I think if there's nothing else major, then also for the sake of everyone's time here to stick to the agenda, potentially we wrap it up here.
Yep.
If so, okay, thank you very much everyone for joining, for your discussions, all the people who gave talks for your presentations, all the people behind the scenes who you didn't see who made those talks possible. Also, thank you very much for all your work. We will have another demo day in about 2 months, as already announced. So please feel free to come join us again then. In the meantime, we have our mailing list info linked. If there's other topics, contact us there, contact us on the Slack, and see you around. Happy holidays.
Yeah, happy holidays to everybody. I think it's the last time we kind of meet in such a big group. So
last time.
I mean, this year. This year.
Thanks everyone. Bye bye.
Take care.
Bye bye.